Neutron powers. The main deal about neutrons is that they're able to rotate protons by 90 degrees. And that makes fusion very likely. And I'm going to explain how that is right now. Because without neutrons, you just would have, say, one incoming proton hitting another proton, and they'll just bounce off each other unless they're both pretty slow compared to each other. The proton-electron pair is freer for exclusion of other pairs, meaning the Pauli exclusion principle has more freedom when there's no neutrons around that are connected to these protons, because it tends to make lines of protons forming lines of protons, and there's a polarization going on. If the protons and nucleus have excessive amount of exclusion capabilities, then the nuclei will become kind of unstable and disordered. So there's a composition sketch here I wanted to show you. I'll just pull this over here and show you this sketch. So the blue circle in the middle is a proton, and an electron gets around the outside. Let me get close to the mic and tell you about this. The blue circle there in the middle is a proton, and it has those 4 dimensions coming out of it and into it. And you see that the one called Hz leaves the proton without hitting the electron. The electron's in red, circling around the proton, and this forms a neutron. 2 of the space dimensions go from the proton out to the electron, and then 1 dimension in red comes in from the electron to the proton, and the 4th dimension leaves the neutron, making a rotation field so that other protons on the left can get rotated by 90 degrees. So the point is here that what I'm going to talk about next is that the collision sequence sketch. So we're almost at the end of this presentation. Here is the sequence sketch we can see here. Let me zoom in on that a bit. And before the collision, we see here there's a deuterium on the left here, and on the right is a proton coming in. It's going to collide. It's going to come across here and hit this proton. And notice that the EX direction here is the direction of travel. But it gets rotated. When it gets very close here, you can see that arrow now is pointing up in this direction. So it's been rotated clockwise. And then at the bottom, when it's finally, the collision has occurred, both protons have been rotated clockwise, and their velocity's been blunted. And that's what the description is talking about here, that the neutron rotates both protons. And after this dynamic rotation occurs, the linear velocity turns into a rotation, and the proton contact is stable without a high-speed collision. These 2 velocities of the 2 protons become tangential, so no collision exists. And that's the diagram, and that's the end of neutron powers discussion. Thank you very much.